Hi everyone, here's Yair and Peter to give you an insight into the new Phase 1 solutions for multispectral imaging. The background for what we're going to show you today is 4 or 5 years ago when Yair and we were at an event in London together with our partners from the US, Mike and Bill, and we saw that the theme of multispectral carried a lot of interest, such that a normal, let's say small event, suddenly had 100 spectators on the day. We followed that line of interest and we're going to show you what has come out of this. So speaking of multispectral, we need to see that in the context of cultural heritage imaging, which we took a special focus at 5 years ago. We had seen Phase 1 products, digital bags, systems, get into museums and archives over many years. But the past 5 years, we have concentrated our efforts, learned what the customers are actually asking for, refined the solutions, and that has brought us into a range of cultural heritage institutions, museums, libraries, archives, and on the slide you see some of the more iconic places, but our reach today is worldwide, and it is from the largest institutions to small specialized institutions.
Following the development of other products that we have for cultural heritage, we realized that the key thing beyond the obvious, which is image quality, which is something we've always been doing pretty well, is automation. And from automation comes ease of use. We have this theme called the 1-button or the 5-button workflow, where we think about what a typical customer will be doing during their day, and we try to simplify things and make a lot of the stuff happen in the background. So for the end user or for the customer, and in the multispectral case it would be a scholar, for instance, or a scientist, a researcher that's not necessarily trained to be a photographer or has any specific understanding in image making, for instance. So they need a system that can capture a sequence or a stack of images that they can then look at either visually or inspect it with some other pieces of software that we will go through. So things like what we did a couple of years ago with autocolumn, for instance, with moving the camera automatically to set up a resolution, and with bringing the IXG into the market. And we know that the IXG can do very accurate focusing very repeatedly as well, and very reliably. So much that some of the other companies or foundations that we work with, they actually utilize the IXG for things like 3D scanning, because they know how to control the camera, because they know how to repeat the same focus point and maintain distance. And this all kind of guided us when we looked at the multispectral, and we looked at what do people use these days, or what were people using until now when they were doing multispectral imaging. And you see a lot of different things that have been done manually. They can be done very well, but it's a manual process where people need to focus the camera manually, for instance. They need to replace filters manually, and that also affects the results, and it also affects the consistency of the results. And we are trying to move away from all of this by taking the IXG, which we know can do a lot of clever things, and by selecting a fairly wide, I would say, range of components. Some components we developed, some components we work with other companies, with other partners who can help us. And by doing some clever things behind the scene and making things connect to one another, we can actually make a fairly large system work seamlessly and do everything in an automated way.
So when we speak of multispectral imaging, you could say, hey, why has this come up over the past years? And a key element from the technology side is the development of LEDs. Because with the LED lighting technique, you are able to specify very accurately very narrow bands of the spectrum. And this means that you can actually devise a light that will give you at the one end UV at certain wavelengths, and you can move through the whole spectrum devising the light to deliver wavelengths that cut up or that slice the spectrum into a number of separate light sources. And with each light source you can light subject matter on a table or on a stage. And having done all the captures using the different narrowband lights, you can actually build the stack which you can use to inspect the image.
People have been using, or this technology has been used for quite a few years with digital cameras, before that with film. But the essence of it is to be able to see what the naked eye or what the human eye cannot see. The objects or the subject matter can be paintings, for instance. It's quite a typical application where different wavelengths or different pieces of the spectrum, or by using these different pieces of the spectrum, you can look at the painting and look a little bit deeper and a little bit deeper and a little bit deeper still. And normally you would be looking at UV or ultraviolet lighting, which is the shortest wavelength. And by shortest, in a practical term, you're looking at the surface of the painting, for instance. Then you can use UV with some filtration, and that lets you look a little bit deeper into the painting. Then you have things like foundation, or you have things like varnish, and then you can look into the actual paint or the actual pigments that were used by the artist. And again, each of these pigments might behave slightly differently when you change the wavelength, or when you change the type of light that you're using. Of course, the painting will also have the canvas, and underneath the canvas you still have the wooden frame, for instance. Somebody wants to inspect insects inside the wooden frame and things like that, they will be using other methods. They might be using X-ray or things like that. That we basically deal with the surface and a little bit deeper. What that means in a practical way is that if I'm a conservator or I do some research over an artist's work, and I can see that this part of the image might have something different happening in it, because I can see that the tones or that the color of that area is a little bit different than the surrounding. Or I have some other information that tells me that that area in the painting may have been retouched at some point, or maybe somebody else was trying to fix a few things. And what I would like to do is I would like to investigate that area in the painting without physically touching it, without needing to use a knife and take a piece of the paint or a piece of the varnish off. And by using multispectral imaging, that's exactly what you can do. And the whole point in putting a 100 megapixel camera behind it is that whatever you're doing it at the highest quality. So when you look at this wavelength and this wavelength, you're still using 100 megapixels.
So you could ask, so what are the applications of the multispectral imaging? And there are many, but from our years of research and getting into the matter, we have seen two main areas of application. One related to make unreadable documents readable, from old scrolls, from old parchments, from old documents. Getting readability is one key application area. And the other one, Yair just touched upon, the analysis of paintings and documents for authenticity, to see, is this a real Rembrandt? Is this a real painting by a certain painter? That is a very important application. And what is it that multispectral does? Well, what it does, it gives you a non-invasive way of getting into the analysis of these matters. You don't need to take off paint. You can look into the painting or the document and get a very good idea of what is on the top and what is behind the scenes. You can do this very quickly, and you can do this as a first step to more invasive methods, which are also, of course, used within the conservation industry. So those are examples of the multispectral imaging, and one interesting example from Copenhagen, from the Museum of Contemporary Art. We analyzed a painting that is supposed to be painted by a Dutch painter called Peter Bruegel the Elder. Actually a very valuable painting if it is actually painted by Peter Bruegel. And by doing the multispectral imaging, it turned up that in the right top corner on the infrared reflective image, suddenly the signature came out, the year of the creation of the painting. So just as an example, this is a major finding from something that has been discussed for many years by many experts. So evidence is pulled to the table using multispectral. We are in our solution to support the different application areas. We have chosen to make available solutions on the one side for visual analysis of a certain range of images, and on the other side of more scientific analysis of images. And I'll just continue my side of the conservation community, where a certain method called the charisma method was devised or was developed with the British Museum as a core member. And this method is well documented and gives a range of multispectral images to be captured and to be combined into a few extra false color images to be visually analyzed, and that has proven to become a standard within authentication and evaluation and analysis of paintings in the community of conservation.
So Peter mentioned that for this kind of work, normally the tool that is used for inspection would be visual analysis. So it could be a group of scientists or scholars or conservators, and they will be looking at an image under normal light, under infrared light, under UV light, and try to understand what part of the image shows what, whether it's damage, whether it's retouching, whether it's an area that has some water damage underneath or fungus and things like that. Now it can be done on a large screen, looking at things at 100% focus, so it's easy to notice any small detail, any small imperfections. Almost the other side of it is creating images that can be explored in a very different way. So instead of a group of people looking at images and trying to understand what it is that they're seeing, people will take a stack or a sequence of images and run them through some statistical analysis software. For instance, if people are familiar with something called ImageJ or MATLAB, and they have some custom modules inside, so it's done in a very mathematical way by taking values of this pixel and mixing it up with values from another pixel, and then comparing different images and looking at these values and trying to either accumulate them or subtract some areas. And then what it can do, for instance, is it can make a piece of text that nobody could actually see very readable. So even if you look at a piece of paper that's burnt or that's got drowned and been sitting on the bottom of the ocean for 70 years, things like that. After a little bit of this analysis, you could actually look at an image and be able to read it. Sometimes they don't really look at the image. Sometimes they just look at some graphs or some Excel sheets or some tables full of numbers. But that teaches these people a lot more about the object, about the surface and what's underneath the surface. Here is, I think, where we can kind of turn to the actual product. So what it is that we actually made and what it is made of and what's included and so on. Okay, so I mean, you can see what's on the copy stand in front of us. You will be familiar with the IXG. It looks like a normal IXG. It's kind of a normal IXG. It is missing the infrared filter in front of the sensor. So instead there's just a clear glass filter. The camera model is slightly different, so it's called the IXG 100 wide spectrum, or WS as we would like to call it. You can see that it sits on a normal copy stand, but it actually sits on a special rail that is designed as part of the solution. And this black flat thing in front of the camera, this is a filter wheel. So it's a square housing, and inside there's a carousel with 5 holes. And in each hole there could be 1 filter or 2 filters, depending on the configuration and depending on how it's being utilized. And there is an accessory that sits between the camera and the filter wheel, which is designed to basically block any stray light from coming through. The reason is that if you're using filters in front of the lens or in front of the camera, you want light to only come through the filter and through the lens. You don't want any light to come from the sides and reflect, because that light obviously is not filtered correctly, and it may affect the images and it may create some funny artifacts. Then we have lights, and in this case Peter mentioned the Charisma workflow, and Charisma basically produces a set of 8 images. So 6 images are captured with visible light, with UV, with infrared, and with filters and so on. And then you have 2 images that are called the false color images, basically where some of the channels have been swapped. It kind of helps some people look at some of the detail and makes it more obvious to see. The lights that we're using come from a German company called Dedolights, and as you can see on each side, basically it's 2 banks, but they are very similar. So you have UV at the front with another UV filter in front of the light itself. Then there's visible light, which is the yellow one, and then there's the infrared, which is the red at the back. We made them all sit on a nice rail, and that rail can actually be moved in and out and adjusted. It's all very portable, so it all breaks down and packs into a wheeled bag, basically. They all have their power supplies and cabling and all that. And the software that we have basically tells which light to turn itself on at what sort of timing, with the correct filter in front of the lens, and so on and so forth. We mentioned the narrowband, and when it comes to narrowband, we are talking about lights that can basically cut the spectrum into 16 or even more very narrow pieces of the spectrum. Basically, it's a custom-made panel. I don't know if it shows, but there are 16 different LEDs inside, each set with a specific frame and a specific filter in front. They are quite powerful, and there will be, of course, 2 of them. So again, 1 on each side. Again, they have USB connectivity. We have 1 fairly large USB hub that kind of gets everything connected to. They're all connected to a computer. And the computer runs something which is called Rainbow, quite surprising. But this is the software that we developed specifically for this kind of application or for this purpose. And I think we can try and show you like a basic demonstration of how the software works.
Maybe a word of flexibility just before we come to that. If we look at the system, the idea is to make sure that the system can be tailored to the application areas that work with conservation, that work with libraries, looking into documents that need to become readable. We even see application areas within the police where forensic analysis actually use the same type of analysis. So when we look at flexibility and mobility, we've chosen to work with a 100 megapixel RGB sensor without the IR filter in front of it. This means that we have the option to actually put an IR filter in front of the camera. If one day you wanted to do normal copy stand work or normal photography, so that the solutions we are offering here is complete flexible with regards to multispectral analysis, imaging, or normal copy work on a copy stand. The filter wheel is configurable so that the inside of the filter wheel, if down the line a customer needs to do very specific filtering, what you do is you can take out the carousel and you can configure that according to specific needs. We of course deliver a fully configured solution for the main applications, but down the line there may be flexibility for other solutions. And on the copy stand side, I think you are aware that the copy stands that Phase 1 offer in our cultural heritage solutions, they contain a number of unique features where the auto column is one, where the cable, the nice cabling is another one, where you have the option to put in a backlit top on the table, and there are even more options. So on the copy stands we have flexible solutions.
This is a Rainbow, the Phase 1 Rainbow software, which is part of the Multispectral or MSI solution. To highlight some of its key elements, first of all, it is based on years and years and years of experience and feedback that we've had from top customers, top institutes. It does everything automatically, including calibration for focus, alignment, and all the relevant exposure parameters. It can control the camera, the lights, and the filter wheel all at the same time. It's basically a one-button, robust, repeatable, accurate, and a very, very simple solution. What it produces at the end is the perfect stack. The stack is also normalized in terms of the chosen lighting method. So whether you use multiband or narrowband, the perfect stack normalizes all these images to work together. And it is customizable. So when you create a recipe, you can actually customize it to a very specific user requirement. We designed it to be very, very basic, very, very straightforward. It's not Capture One. It doesn't have any sort of adjustments tools or editing tools or any creative corrections to an image. It's designed to do exactly what you need for multispectral imaging, meaning creating a stack or creating the perfect stack. So when it comes to the workflow, we broke it into 5 basic steps. One is kind of management. It's where you create a project. So you start here and you will create a new project. You can name it and decide where you store the images. Then you will create a recipe, and by recipe we mean what is it that you're actually using in terms of the lights and in terms of settings of the camera. So we know, for instance, that for specific wavelength you need a longer exposure. for instance, that's where you set it up, or higher ISO, that's where you set it up. Or when you use a specific light with a filter, again, you need to change exposure and so on. So you can create your own recipe, but of course we want to make your life simple. We created 2 or 3 or 4, let's say, factory recipes that are designed around charisma workflow, which is what we call the multiband, which is using the deader lights and using the filter wheel and creating those 8 images. In a similar way, when you use the narrowband lights, when you use the LED panels, you can then select what we call Eureka, because that's how the lights are called. And again, you can select Eureka with all the different wavelengths, or you can specify the ones that you actually need for that kind of object. Then there's a very, very important tool for calibration. And when I talk about calibration, there's several things that need to be calibrated before you start a project. So it's a little bit like when you do normal reproduction work and you change lights and so on. Oh, I need to do a new LCC. It's kind of similar, but of course it's a lot more advanced. So things like focus calibration. And we keep mentioning focus calibration and how the IXG can focus. The whole idea is that when you change wavelengths, because your focus plane changes as well. That means that when you shoot something with visible light, that's all fine, that's all nice and sharp. Then when you turn on the UV light, suddenly your image is a little bit softer, because obviously your focus plane moved a little bit. The software and the camera will recognize the target, recognize specific coordinates on the target as well. It will also do calibration of, let's say, LCC. We call them flat field correction. Okay, so once you've done the calibration, here comes the interesting part, and that's where we capture. Within the capture thing, we have a live view image. So you can see that I can actually move the objects and set up my composition. To make life easier, we can actually turn on the visible light. Okay, so it's not just for us to do the composition, it's also for the camera to be able to see things a little bit better. And again, this is by the software instructing the power switches to turn the lights on. And there's a way of doing manual focusing here as well, so you can override things if you wanted, but typically you will use autofocus. And the next thing you need to do is, of course, put the goggles on, because we are using UV lights. And when you press capture, I'll just step aside. I don't know if you can hear, but you see the visible light turning on. Maybe you can hear the camera moving up and down a little bit. So the camera basically recalls the last position that it had in its calibration. So it's taken the visible light image. And now you can actually see, you can see the UV light reflecting. It's turning on the UV lights and taking the UV image. Of course, when it comes to infrared, you might not be able to see anything, and it's a fairly long exposure, but when it's complete, we can actually use the voice control in the operating system, and we can actually tell you when the process is complete. We can tell you which wavelength is currently being captured, and so on. The idea behind it is that during normal work, because the room needs to be completely dark, the screen will also turn off. So you need to have some kind of a vocal feedback that something is happening. And I think it's done. And then you end up with a stack. So in our case, we have the deader lights running through the Charisma workflow, and we ended up with a stack of images. And again, it's a basic browser, so it allows you to inspect the images that you captured. As you capture, these images are actually being processed as a 16-bit TIFF. And the reasons for that is this is the requirements set by Charisma, or this is the normal requirements when you go into statistical analysis. So if it's Charisma, the images will be colored, and as I mentioned, there will be 2 images that are false color. If it's narrowband, we actually process the images into black and white, because that's how usually all these statistical analysis software want to use them. And in that case, you will end up with a much larger stack. So it can be 16 images or 25 images, and many more. But when you look into, for instance, this stack, you can actually go through these images and see what the system captured during the process. And you can see that obviously they have a different color. And we normally, for our testing, we use a different range of bits and pieces that we know that can show certain things. So we used it not just to check let's say the result, but we also use some special objects that tell us whether the alignment has been done correctly or anything else. Maybe the final piece of the calibration and processing is what we call alignment, which is making sure that all these images, be it the 8 images or the 16 images or the 26 images, are all aligned in terms of dimension and size. So if you do need to get them into statistical analysis software, you don't want pixels to start jumping around. You want every pixel to stay where it is. That's the whole point. So yeah, it runs on Windows, although theoretically we should be able to compile it for any kind of operating system. As you can see, we're running it on a laptop. It's a fairly powerful one. It needs to handle quite a few devices running together, and as well as processing. So there's a fairly powerful processor inside, lots of RAM as well. The system actually comes in 3 suitcases with wheels. One includes, of course, the camera and all the various bits and pieces that are required for the camera, including the filter that Peter mentioned that you use for taking some normal images. And that filter comes with a magnetic adapter, so it's easy to put on and off the lens. Second suitcase will include the filter wheel and everything that's required for it, the cabling, power supply, the special rail that holds everything together, and the computer. If you're asking why the computer is included, is because we see it as an almost like an integrated part of the system, because we want to make sure that when you use it, you have the best sort of performance, let's say reliability, in terms of what connects to what and how stable the connection is. The last suitcase includes the narrowband lights, but that also depends on how you choose to configure the system, because you can use the camera with a laptop with these lights, or you can use the camera laptop with these lights, or you can use the camera and laptop with all the different lights together. Again, depends on your needs and requirements.
What you should know is all components here are standard components. They are tied together, standard USB. They are controlled from our software all the way through. There is a full user guide for both configuration and operation of the system. As I mentioned in the very beginning, we have partners in the markets, specialist multispectral partners or associates. And in some cases, we see that our associates are brought in for a pilot project where we bring in the system, do a pilot project such that management can be convinced, whoa, this is the right way to go, before an investment can be made.
These next few slides show you a breakdown of the components or what is actually in the box. So you essentially have 5 main components. One being the camera and everything that comes with the camera. 2 being the what we call the MSI accessory kit, and that's the filter wheel and a few other bits and pieces. Number 3 is the multiband option that is used for Charisma. Number 4 is the LED panels or the Eureka panels that are part of the narrowband solution. And number 5 is the optional copy stand, which is available through phase 1 as well. So number 1 and number 2, when we talk about the camera, it's the IXG 100 megapixels wide spectrum. Normally comes with one lens, of course. A second lens and extension tubes and so on can be ordered in addition. But part of the wide spectrum camera kit, you get the special lens shade or lens hood that blocks out any kind of a stray light, and the magnetic filter holder and the filter itself that blocks out infrared and UV light. In number 2, you get the filter wheel already assembled with all the correct filters pre-installed. These filters are suitable for the Charisma workflow. The filter wheel is configurable, so if somebody develops a very special workflow, they can get additional filters, remove the carousel from the inside and change the filter arrangement. In the same suitcase, you get a special rail, the custom rail that holds the camera and the filter wheel on the copy stand, works on any copy stand, and the laptop already with Windows 10. It's a very powerful Dell laptop, and of course it comes with its power supply and adapters and so on. Number 3 and 4. 3, as I said, is the multiband option. So you basically have 2 sets of 3 lights each, with the power supplies, with the custom rail that holds them together, and with the USB controlled power switches. The whole thing comes in a wheeled bag or wheeled case, and it also includes the filters that sit in front of the UV and the visible lights. In number 4, it's the Eureka lights, Eureka panels. Again, they come in a custom suitcase with their power supplies, mains adapters, and USB cables, as well as the USB or the 7-port USB hub. When we look at the multiband solution, this is what it's going to look like. So you will need number 1, number 2. Number 2, as I mentioned, includes the software and the computer as well. Then you have the lights with the power supplies. We do not supply the light stands. These will normally come from your local phase 1 partner. Then for narrowband applications, you will have the same camera, same computer and MSI accessories kit and software, but you will need the LED panels, the Eureka panels. And again, we do not supply the light stands. When somebody uses everything, when they need to do Charisma as well as narrowband applications for, say, manuscripts, readability, and so forth, you will have number 1, number 2, number 3, number 4, with the software, with the computer, and all of that. And the optional copy stand can come in 3 variations. So one can be floor standing, one can be a desktop one, and one can be wall mounted. Before we conclude, I would just like to recap and run a short summary of what we've seen so far. So the Rainbow MSI solution delivers a fully automated high-resolution capture workflow, meaning that we've based it on years and years of experience and feedback from some of the key institutes and conservators around the world. It delivers a one-button, robust, repeatable, accurate, and simple workflow. The software part of it, the Rainbow software, takes care of calibration for focusing, alignment, and all the relevant exposure parameters. And it takes care of controlling the camera, the lights, and the filter wheel all at the same time. What you get out of it is the perfect stack. Perfect stack means a stack of images that are all normalized according to the chosen lighting method. So whether you shoot multiband or narrowband, depending on the application and how you set it up, you will get the perfect stack. Of course, it is still customizable, so one can change capture parameters depending on the actual subject matter and the specific needs. What we also provide with it is excellent advice and support right from your first stage of research and learning and understanding about what is available and what it is that we are talking about. We have some of the leading experts in the field working for us or working with us. And of course, as always with the phase one, we make sure you get the best image quality. So there you go. Further questions, you can point directly to ourselves. You can speak to the local partner. We have a studio set up in our office in Cologne, where we can actually do virtual online demos, or we can do tests, specific tests. If somebody wants to send us an object, I know it can be quite tricky, but if you want to send us an object, this is something that we can arrange for, and we are planning to use this facility as much as possible. Either online webinars, virtual demos, it can be a one-on-one, it can be arranged for a small group, but do speak to your local partner or speak to us, and we look forward to hearing from you and to speaking to you very soon. We are also hopeful that we can actually meet each other face to face at some point in the near future, as soon as things start getting back to normal. So thank you all and stay safe.